So when you've downloaded your files folder, you will first find a C folder. This is the folder where you will have to implement your exercises. So if we look at linkedlist.c, you will see we have here all of the functions that you will need to implement. Of course, currently they're just exiting, so they are quitting with value -1. Now, if you execute make, this will compile your full program and it will generate a linked list executable which you can execute with /linkedlist. And as you can see, this tests your functions. And as you can see, 0 of 7 functions were tested successfully because, of course, I have an empty file here. Now, the reason, so once you start programming, you could check, you could get assertion errors. So we have this linked list test.c, which you don't need to edit, but here are the different tests we do. So if you're going to implement linked create test, let's say we start working on this. So let me open linked list.c in a different tab. So when we look at this test suite, for the list create test, we see there is one thing being checked, and that's basically if list doesn't return null, or if list create doesn't return null. That would mean there's something wrong, because list create needs to allocate space on the heap, and that can never be the null address. So this is a simple test. Now let's see what happens if we simply return null here. So we do exactly what the test tests that we don't do. So this is of course, wrong implementation of list create. If I now execute make, and what you could do is execute make, and then, where is it? Use this command to quickly execute your unit test. And what you will now see is, well, now my tests here, since they all start with a call to list create, they are failing using this message, assertion list not equal to null failed. So these assertions that you see in this list test file, these will be printed to your output whenever one fails. And so you can go look here, if a certain assertion fails, you can just check out why. All of these assertions are things that have to be true. So whatever is within this assertion needs to be true, needs to be correct. If it's not, you have a mistake in your code. Or we have a mistake in our test suite, which is also possible, but less likely. So whenever you get an assertion failure, go into the test suite here, check out what is the expected value, why does this assertion fail, what did you do wrong. And this way you can do test-driven development basically. So hopefully this will speed up your process of correctly implementing these linked list functions. Now, in the simulator, I've opened the file in ASM, the main file. So in the simulator, we're doing something very similar for RISC-V. We have this main file, and this main file contains the main function. Now, if I'm going to try, let me unclick this for a second. If you just open this file and you try assembling it and you get the message, symbol run test suite is not found, well, in that case, you need to toggle here, assemble all files in directory. So this entire ASM directory contains all of the functions you need to implement, also an implementation of malloc, which you can use, and our main file here, and of course this test suite. So let's open that one too. And once you enable this setting, whenever you press assemble, all of these are considered one big file. And now this works. And if I now run on an empty project, you will get an error. And this error might be very strange. So we couldn't get the exact same result as we did in C because we don't have assertions. So I've hacked basically assertions into the simulator using a trick. What you see here, runtime exception at a certain address, and then load address not allowed to word boundary deadbeef. If you see this deadbeef, that means our test suite has found an error in your implementation, which makes sense since this implementation is empty. And if you want to see what error has been found, well, double click this. And as you can see, my simulator jumped to the assertion that failed. And remember that we check in our list create for the fact that the return value of list create is not null. Well, here's the assertion that I wrote, assert not null A0. So we executed list create and we got a null value or a 0 value in A0, which is incorrect. List create is currently still empty, and by accident the registers contain 0. So this is where your test suite fails. So this is a main tip. Look at this. Double click this error and you go to the assertion in this linked list test suite. Very, very useful. Now, this gel and check that I wrote is basically a special macro. You don't need to know how this works. You could check this code out if you want to, but it checks whether or not you are breaking calling conventions. So if list create, let's say I do something which I am not allowed to do, load immediate S0 5. What do I do? Well, I have a function here and it overwrotes a call save register and it doesn't restore the original value. If I'm going to execute this, my test suite will now complain. Load address not aligned to word boundary. We always get this error, but the address is slightly different. Let's double click and let's see what has failed. Oh, this gel and check has failed. Why? Well, you haven't restored your call save registers. Now, so either you're going to be, whenever you see that beef, double click the error message. If you don't see that beef, then it's probably going to be a different error, maybe something in your code. Double clicking would again lead it to the source line where it failed. But always double click to see where you end up. If it's a gel and check, you probably forgot to restore call save registers. If it's an assertion, well, just look at what the assertion is checking. The test suite that we've implemented is almost the same as a test suite in C. So you could put the two next to each other. If you don't really understand what's going on in the RISC-V assembly, you could maybe check out what is being tested in C. It's probably the same thing. We also tried to provide comments in the test suites to show you what the assertions are that we are testing. So this should help you implementing and checking if your solutions are correct. If you can pass the test suite, it's very likely that you have a correctly functioning implementation. So again, we explicitly check what happens if malloc runs out of memory. And also one more tip. When we crash like this, in this case, I did override a call save register. When you crash like this, also look at run IO. We try to give some hints here. So the hint that is being printed here, a function in your interface failed to restore all values or call save registers to their original values. This breaks calling convention. We are going to let the program crash by loading address .beef. Check the line number in the rars error message to find the faulting function call. And then ignore the actual error message, which means this error message, because that's just the hack we use to be able to allow you to double click this and see exactly what has failed. If you're interested in how we implemented this hack, basically we just define a macro, different macros for each assertion, and then we call fail, which is a different macro that we defined. And what does fail do? It loads the address .beef into T1. .beef is not a multiple of 4 because it ends in F, which is 15. So this is not a multiple of 4. So this is a load address not allowed to word boundary because LW needs a multiple of 4. But since we used the macro, it's going to highlight the macro that failed and luckily not something in the top of this file. What are macros? Well, these are basically instructions. So the instructions in the macro are going to be pasted wherever we call the macro, and we can call some parameters. So this is a way to define your own custom instructions that are based on other instructions. So if you assemble this, all of the macro calls will be replaced with these instructions. So that's how the test suite works. You can start implementing, you can run, and then you can see what the test suite gives you, double click it, and see where your function went wrong. One more thing in the main function. So you see we call simply the test suite and then we exit. You could write some own testing code before running the test suite. You could comment it out if you want to for a while. If you're debugging yourself, always possible. And maybe just one more tip. Let's see what happens. This instruction eBreak, it's a new one. If I put it here, what is going to happen is whenever code reaches this point, the debugger is going to pause. So at this point, our assertion will not have failed yet because the function is not yet done. Let's say I execute now everything. Well, list create is going to be called in the test suite, and look, execution paused at breakpoint. And now you can see, so we are actually in this file. We are in this code right after, in this code right after the li call. As you can see, we executed the eBreak instruction. So this is a way to place breakpoints for the debugger in your source code. This can help a lot in these complex projects to pinpoint where your mistake might lie. I think that's it for the tips. Good luck with the implementation. Of course, feel free to ask any questions whenever you're stuck on the forums, of course, in the exercise session itself. And this is going to be the last Risk 5 programming exercise session. The next two will be slightly different. And then in session 9 will be a revision exercise of everything. So in session 9, you'll also get some more opportunities to ask questions if by then you're still working on this and might be stuck on certain aspects. Good luck with the session.